Right, so in this video, let's discuss the remaining 10 questions, which are 4-point questions. Let's start with number 16. How many triangles are there in the figure? As we can see here, the diagram shows us different size triangles. Then let's start with the 1-unit triangle. All right, so it's similar to the question that we've discussed before in 2020 SASMO questions. So the 1-unit triangles, we have 1, 2, 3, 4, 5, 6, 7. All right, so 1-unit triangle, there are 7. I'm going to erase all the numbers, so we're not going to make mistakes in counting a figure twice. Now let's start with 2-unit triangles. So where are the 2-unit triangles? We have here, that is 1, right? And then here 2, and do we have another one? Let's see. Yes, we've got here 3. Okay, so there are 3 2-unit triangles. So I'm going to erase them again. And then what about 3-unit triangles? Have we got any 3-unit triangles? We apparently have one here. You can see that it has 1 unit, 2, 3 units. So that is 3-unit triangles, and the biggest one is 5-unit triangles. So we have 5-unit triangles in these. Okay, as you can see, we have 1, 2, 3, 4, 5, and also here we have 1, 2, 3, 4, 5 units, and we've also got this one. So there are 3 5-unit triangles. So in total, there are 14 different triangles. All right, now let's go to number 17. In a 24-hour period on a digital clock from 00 to 23:59, how many times does the digit 5 occur? At the time 3:55, the digit 5 occurs 2 times. So now let's make a list. Okay, so let's find the number of 5 that appears in the hours first. Then we know, of course, from 5:00 to 5:59, all of these numbers have 5 in them, right? And then the next time that will show us is to show 5 in all of the time that it is showing is 15, which is 3 p.m. to 15:59. We know that from 5:00 to 5:59, there are 60 times it appears, right? So 60 times here, which means 60 minutes. We only count the number of the time with 5 in the hours place first, okay? So let's not mind the minutes yet. So this is also 60 times. So the digit 5 appears in the hour 120 times. Okay, now what about the number of 5 that appears in the minutes? And now let's decide that when we're talking about the minutes, we have the ones place of the minutes. So I'm talking about this, okay, the ones place of the minutes and the tens place. So let's talk about the ones place first. How many times does 5 occur? In every hour, so let's say 00:05 until 00:55, then we have 6 times the 5-digit appearing. All right, so like 5, 15, 25, 35, 45, 55. So the digit 5 appears 6 times every hour in the ones place. and there are 24 hours. So we multiply that, that means the digit 5 appears in the ones place of the minute 144 times. Now, what about in the tens place of the minute? So now this is the tens place. Now we can see that in the minute, it can have like 5 in all of the minutes from 0050 to 0059. The digit 5 appears 10 times, and the same goes to 150 until I'll put 0 there, until 159. It also appears 10 times. So every hour, the digit 5 appears 10 times in the tens place. So that means we can multiply 10 by 24 because there are 24 hours, 240. So how many times does the digit 5 appear in the time the clock shows? We can add all of them, 120 plus 144 plus 240. So that's equal to 504. All right, number 18. The following bar chart shows the number of students from Happy Primary School who received 4 different awards in SASMO competition. All the horizontal lines are equally spaced. The difference between the number of students who received silver awards and perfect score was 140. Students who didn't win any award received certificate of participation, and they weren't indicated on the graph. The ratio between the number of students who received gold award to the number of students who received certificate of participation was 4 to 9. Find the number of students who received certificate of participation. So there are some keys you have to understand here. First is this. It says all the horizontal lines are equally spaced, which means we can use them as the number of units. And then it gives us the difference between the number of students who receive silver and perfect score. The difference is 140. So let's see the number of units they have. So perfect score, there's only 1 unit, while silver there is 1, 2, 3, 4, 5, 6, 7, 8. So they have a difference of 7 units, and that is actually 140 people. That means 1 unit here, 1 unit in the bar chart is equal to 20. And then it says the ratio between the number of students who receive gold. So now we're talking about this, to the number of students who receive certificate of participation, which is not shown here, is 4 to 9. Now we can find the number of gold awardees. So that's every unit is 20. Gold means 3 times 20, 60. So now gold to certificate of participation, or what, CP. So is 4 to 9. If the gold awardees are actually 60 people, then it's multiplied by 15. So the number of students who receive the certificate of participation is 9 times 15, which is 135. Okay, this is pretty much basic ratio that we learn in the class. What you have to understand is this and this. Okay, so you can write the equation of the units. Next, number 19. A pipe can fill up an empty tank in 18 hours. A full tank can be emptied by a pump in 20 hours. How long in hours will it take to fill up an empty tank if both the pipe and the pump are turned on at the same time? So this one should be an up. Apologies for that. Right, so now we can see that actually the pipe fills the tank faster than the draining by the pump. Right, so now we can say that the pipe, the rate of the pipe is to fill 1 tank in 18 hours. So like per hour, it's 1/18 of the tank. Okay, while the rate of the pump is to drain the whole tank in 20 hours. That means every hour, okay, the pump can drain 1 out of 20 of the water in that tank. So what's the difference in their speed? That means we can subtract 1/18 minus 1/20. That's equal to the lowest common denominator of 18 and 20 is 180. So times 10, this one times 9. So that means the difference is 101 out of 180. What it means is that to fill up the tank with the difference in the rate, to fill up the whole tank, it will take 180 hours. All right, let's go to the next question, number 20. Ren selected 20 different whole numbers greater than 0 such that the product of any 9 numbers is always even. The sum of the 20 numbers is an odd number. Find the least possible sum of these numbers. Okay, so in this case, we are going to apply number sense. Okay, it says that the whole number is greater than 0, so it starts from 1. And then the product of any 9 numbers is always even. So the product of any 9 numbers in the 20 numbers. All right, you have to understand that odd multiplied by even number always ends in even. Right? Well, odd times odd, it is odd, like 3 times 3, it's 9, 3 times 5, 15, 7 times 7, 49. So what you have to understand right away here is that if you need to multiply any numbers, any 9 numbers, and the result must be even, that means the most number of odd numbers is only 8. You will multiply the odd by odd. Okay, by odd, by odd, by odd. They will end up as an odd number, but then you will multiply that by one even number. Then it will turn into an even number. So you can make sure if you have only 8 odd numbers in the 20 numbers, then your product of any 9 numbers that you take will always be even because you will always multiply by an even number. Okay, so now we know that the maximum number of odd numbers we can have is 8. But then it also says the sum of the 20 numbers is an odd number. Now, what does this tell us? If we have 8 odd numbers, okay, now another number property you have to know, odd plus odd will always be even. But when you add even and odd, it's going to be odd. So it means you cannot have 8 odd numbers. They will, if you add 8 odd numbers and then the rest are even, the 8 odd numbers will result in an even number as the sum. Okay, so to make the sum of the 20 numbers an odd number, you must have only 7 odd numbers. All right, and the rest must be even. So knowing this, and we have to find the least possible sum. So let's arrange the first 20 numbers that contains only the first 7 odd numbers. So they are 1, 2, 3. So remember the odd numbers that we have included. 4, 5. I'll underline the odd. 6, 7, 8, 9, 10. 11, so we've got 6 odd now. 12. Now it's the 7 odd number. That's the last odd number we can have, and the rest should be just even. So 14, 16, 18, 20, 22, 24, and 26. Okay, so let's add all of them up. So 3, 6, 10, 15, 21, 28, 36, 47, 47, and then, do I count that right? Sorry. So 15, 21, 28, 36, 45, 55, 66, 78, 91, and then 105, 121, 139, 159, 181, 205, and 231. All right. Now let's go to number 21. The big square on the right is made up of 4 rectangles and 1 small square. The length and the breadth of 2 rectangles are given in the picture. Find the perimeter in centimeters of the big square. Right, we know that this here, I'm going to shade it, it's a square. Okay, so we know that the sides are all equal. So, okay, so let's say that this is an x, okay? So we are trying to find out an equation from this. Let's say that that is an x, then the length here must be equal to 11 minus x, because this is 11, right? And then we also know that this is going to be 11 minus x as well, because they're equal, while the length here is equal to 5 plus x plus 3 centimeters, so 8 centimeters, and the length of the square. Okay, if you don't understand the x, so let's just say that it's 8 centimeters plus the length of the square, and this is 11 centimeters minus the length of the square. So actually this side can be written as 18 centimeters and minus the length of the square, and the 18 centimeters minus the length of the square should be the same as the 8 centimeters plus the length of the square, right? So we can say that 2 units or 2 of the x's is equal to 10, which means x is actually 5. So the unit here is actually 5 centimeters. So the length of the square is actually 13. So what is the perimeter of the big square? It's 13 times 4, which is 52 centimeters. All right, and remember, when you are answering the questions in SASMO on Friday, all the answers must be written in whole numbers. Most of the times, the answer you find are always whole numbers. And even if you get a decimal, you have to round it off. Okay, only write the answer in whole numbers. Now let's go to number 22. In the following cryptarithm, all the different letters stand for different digits. What is the value of the 4-digit number AECA? So in this case, you should understand that all different letters stand for different digits. Make sure you follow this condition. All right. Now let's take a look at which letter we can start off with. Okay. So A plus A is C. We just know that A represents the same number, but it can be anything. It can be 1 plus 1 is 2, 2 plus 2 is 4, so that can't really tell us anything. C plus E results in E, that's also not clear. A plus C is D, of course, a different number added to a different number will end up a different number. But here, E plus A is A. Then we can tell something about it, that one of the number must be a 0. Then when you add to another number, the number doesn't change, right? So E must be a 0 here. Then you can also see that this is a 0. This is now a 0. So now 0 plus 1 is a 0. You cannot say C is a 0 because they must be a different number. So C must be 9, and it will get 1 from the sum of the tens place. So now I'll put 9 here, 9 here. Okay? And then which one can we do next? We can tell the result of A, because 1 plus 9 plus 0 is 10, then it will get 1. So A must be 4 and 4. So this one is 4 and 4. And if we know that this is 4, then D must be 3, because 4 plus 9 is 13. Right? So what's the number AECA? AECA is 4094. Then number 23. Shells are being distributed into a fixed number of boxes. If the shells are distributed into groups of 14, there will be 6 extra shells. When shells are grouped into 16, there will be a shortage of 84 shells. What is the total number of shells? Okay, so let's write down the equation for the two conditions here. So first, let's start with this. So the number of shells is equal to, when we group them into groups of 14, that means there are 14 units, okay? 14 times the number of units, and then there will be 6 extra shells. So there are 6 more, the remainder. But then the same number of shells, if we group them into group of 16, it will be 84 short, which means it's not enough. So now we can see the difference in this case. The difference is 2 units, and that is equal to 90 shells in the difference, right? One is plus 6, the other one is 84 short. So 1 unit here is equal to 45. So now what can we tell? The question is asking us to get the total number of shells. So we can say 14 times 45 plus 6. So 14 times 45, 45 times 10 is 450. 45 times 4 is 180. So 630 plus 6, so that's equal to 636. Or we can test it with this. 16 times 45 minus 84. So 16 times 45, 10 times 45 is 450. 6 times 45 is 270. So that's equal to 720 minus 84. That's also equal to 636. So that's the number of shells. Next, number 24. For question number 24, I believe there is a mistake in the question and there is no correct solution to this. Okay, some of the hints are miswritten here, misguiding. So now let's skip this one and let's go to 25. Stan got some notebooks and pens from a bookstore. The price of a notebook was $7 and the pen's price was $3. There was a promotion: buy 4 notebooks, get 5 pens free. He spent exactly $82 in total and enjoyed the promotion to the fullest, such that he got the largest combined number of notebooks and pens. What's the total number of pens, including the free ones that he got from the bookstore? So the easiest way to do this is to write it in a table or a list. Okay, because we know that he spent a total of $82. So let's just try to find out the different combinations we can have to get a total of $82. So the total has to be $82, and the price of the notebook is $7, while the price of the pen is $3. So it can be 7 times 10 books. Okay, so this is number of books. 7 times 10, that will make 70. And then that means the number of pens is 3 times 4, which is 12. And you can see that the total makes $82, right? So, so if he buys 4 notebooks, he gets 5 pens free. Now he buys 10 notebooks, that means he can get 10 pens free. So now let's find the number of items he get. He get 10. This is number of items. So 10 notebooks plus 4 pens, and then plus 10 free pens. So in total, 24 items. And now we can have the next combination. What about if he buys 7 books? Okay, that makes $49. And then he can buy 11 pens, which is $33. Of course, you have to try to compute the different combinations you can have first in your head. So now the number of items he gets is 7 plus 11. And then because he buys only 7 books, then he can only get 5 free pens. So in total, 7 plus 11 plus 5, that's 23 items. And then we can have 4 books, and that makes $28. And also 18 pens, which is $54. So that means he gets 4 books plus 18 pens plus 5 free pens. In total, he gets 27 items. Or he can only buy 1 book, which is $7, and he buys 25 pens, which is $75. So In total, he gets 1 notebook plus 25 pens, no free pens, which is 26. So the biggest number of total pens he can get, including the free one, is this 23 pens. Okay, so the answer is 23 pens.